All right, let's jump right in. We're going to talk about something that sounds like it's straight out of a movie, but it's happening right now, mostly in the shadows. We're talking about a massive, high-stakes AI arms race, and the prize is control over the very services we all rely on every single day.
So first things first, when you hear critical infrastructure, don't just picture a bunch of computers in a server room. Think bigger. We're talking about the actual physical stuff that keeps our world running. You know, the power grid that lights up your house, the treatment plants for the water you drink, the transportation networks that get you from A to B. That's the battleground.
And that leads us to the big, and honestly kind of scary question we're digging into here. What happens when someone decides to weaponize artificial intelligence and point it at all of that? Let's really get into it.
Okay, so the first phase of this whole thing, it's all about information. It's this high-tech game of hide and seek, a digital cat and mouse. The goal is simple. See everything the other guy is doing while making yourself completely invisible.
And here's the fundamental tug-of-war. On one side, you've got the attackers. They're using AI to get this, godlike view of the battlefield, finding every tiny crack in the armor at a speed no human ever could. And on the other side, the defenders are using their AI to spot ghosts. Threats so good at blending in, they look just like normal, boring network activity.
And these aren't just generic tools. The attacker's AI is incredibly specialized. I mean, think about an AI that can read through thousands of pages of boring technical documents just to find one misplaced password, or one that sifts through millions of lines of code to spot a single vulnerability. They can even clone a person's voice to create a phishing call that's impossible to tell from the real thing. It's all about massive scale and pinpoint accuracy.
So how do you fight that? Well, the defender's AI plays a totally different game. It's not looking for bad guys it already knows about. Instead, it spends its time learning what good looks like. It creates this perfect baseline, this digital fingerprint of the network's normal heartbeat. It knows the rhythm, the timing of everything. So the second something is just a tiny bit off, even by a millisecond, bam, the alarm bells go off. It's all about catching the threat you've never seen before.
But that's just the opening act. Now the game gets way more complicated. It's not enough to just see or hide anymore. Now it's about actively messing with the other side's AI. We're talking about a full-on digital chess match, played at machine speed.
And this is where things get really wild. Attackers are now creating malware that knows it's being watched by another AI. It's designed to figure out what the defense is looking for and then do something completely different to fly under the radar. So the defenders have to get ahead of this. They basically have to teach their AI how to spot a liar, how to recognize when it's being tricked. So let me walk you through how this actually works. An AI-powered piece of malware gets in, and it doesn't just start breaking things. No, first, it just sits there. It watches. It learns the normal rhythm of the network. Then, it rewrites its own code so it looks like nothing anyone's ever seen before. And finally, it acts incredibly slowly, making tiny little changes over time so that none of the old-school alarms even notice it's there. Okay, so to fight a ghost like that, defenders have to get really smart. They use a technique called adversarial training. Basically, they unleash their own attack AI on themselves to find the weak spots first. It's like being your own worst enemy to make yourself stronger. They also build these super realistic fake environments, we call them honeypots, to lure the bad guys in, trap them, and study exactly how they operate, all in a safe, contained space.
All right, now we're at the end game. This is where the fight spills out of the digital world and into the physical one. We're talking real-world consequences, and it's all happening at a speed that is literally too fast for a human brain to follow. This right here, this quote gets to the absolute core of the threat. Just picture it, an attacker's AI making a bunch of tiny little adjustments inside a power grid's control system. Each one, on its own, looks totally normal. It's so small it doesn't trigger any alarms. But the AI knows that if it makes 1,000 of these tiny, invisible changes in just the right sequence, it can trip the whole system offline. It's a death by 1,000 cuts, all orchestrated with perfect, terrifying machine precision. So how would an AI even pull that off? Well, first, it would build a complete digital twin of the target, say a power grid, so it can run simulations and find the single most critical weak point. Then, it crafts commands that look perfectly valid to the system operators, but are secretly designed to cause a physical breakdown. It can even discover brand new, never-before-seen vulnerabilities on its own to get the job done. You know the saying, fight fire with fire? Well, here, you have to fight a machine with a machine. The defense has to be instantaneous. We're talking milliseconds. The second a defensive AI spots a threat it's sure about, it doesn't email a report, it acts. It slams the door shut, quarantines the infected part of the network, and contains the damage,
all in the blink of an eye. Then, and only then, does it tap a human on the shoulder to say, hey, you should probably take a look at this.
So what you have is this constant escalation, a race that really has no finish line. Let's kind of pull back for a second and look at the big picture, where we are now and what challenges are coming up for both sides.
This here gives you a really good snapshot of the kinds of tools being used. You've got your detection, your response. You'll even see adversarial defense, which is exactly what we talked about, teaching AI how to not get fooled. It's a super specialized field, and believe me, it is changing every single day.
But look, this is far from a solved problem. There are some major hurdles. For one, any AI is only as smart as the data you feed it. Garbage in, garbage out. Plus, a lot of these advanced AI models are black boxes. They give you an answer, but we don't always know how they got there, which makes them hard to trust. And maybe the biggest problem of all? A lot of our critical infrastructure runs on technology that's decades old, built way before anyone was thinking about this kind of fight.
When you boil it all down, you get to this one core idea. AI isn't the good guy or the bad guy here. It's just the most powerful tool on the board. It's the ultimate weapon for the person trying to take down the grid, and it's the ultimate shield for the person trying to protect it. It is both.
And that leaves us with one last really important question to think about. As this whole conflict gets faster and more autonomous, as it becomes machines fighting other machines at the speed of light, where do we, the humans, fit in? Can we really keep up with a battle that's fought in milliseconds? Or are we in the process of building a war that could one day fight itself, with or without us at the controls?